Hello and welcome to another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing unit number 5, lesson number 4 on the equations of lines. Alright, now almost everything that we do in today's lesson is going to be review from Common Core Algebra 1, and that was probably kind of review from 8th grade math. So there's going to be a lot of review in today's lesson, okay, on how to look at the equation of a line, how to interpret it, how to plot it, what the intersection points of equations of lines mean, and we'll also try to bring back things like parallel and perpendicularity from the last couple of lessons. Let's jump right into it and get into a little bit of the review of this subject matter. Alright, now you've been seeing equations of lines for quite some time. Most of you have actually been probably seeing them since about 5th grade, okay? Granted, you may have only been plotting on sort of this portion of the axes back then, but you did see these kind of relationships. So let's jump right into exercise 1. Without the use of your calculator, identify the slope and y-intercept of each of the following lines and then plot them on the grid shown. Label each with its equation. Well, even though we haven't done any line plotting per se based on equations, this is not a bad point to ask you to pause the video and see what you remember about equations of lines and how it can help you plotting them. So take a few minutes now and see what you can remember, and then obviously we're going to come back to it in a bit. Alright, let's go through them. Whenever we have a line that's written in what's called y equals mx plus b form, the coefficient on the x is the slope. So in this case, the slope of this first line is 2. And if you want to think about it in terms of rise and run, right, you'd maybe want to plot it like this. A rise of 2 and a run of 1. Okay. Its y-intercept, though, where it intersects the y-axis, is the constant that's added on. All right? So before we plot the second line, let's go ahead and take a look at this one. It's pretty easy. What we'll do is we'll come in and we'll plot the y-intercept down here at -7. And then we'll use the fact that the slope is 2 over 1 to do a run of 1 and a rise of 2, and a run of 1 and a rise of 2. This picture is going to get kind of ugly soon if I keep doing that. Now, as we've talked about extensively in this course, of course, once you have 2 points on a line, technically that's all you need. But we know how inaccurate line plotting can be and things like that. So it's kind of nice to have a variety of them before we take our straight edge out and let it do its thing. So let me now kind of connect these things. All right, like that. And get rid of this for now. Double arrows, okay. And I want to label it with its equation. It is very, very important when you're plotting more than 2 things on the coordinate grid that have equations that you label them with their equations so that somebody who's looking at your work can properly assess which one is which. Let's take a look at the second equation now, wherever it is, there it is, and see what we can say about that. In this case, the slope is -1/2. Now I can interpret that then, right, again, rise and run. And from a previous lesson, you know that probably what this means is that these 2 lines are perpendicular to each other, but that's not really part of the problem. The y-intercept is 3. So again, just like before, let's go in, y-intercept of 3. Let's go with a run of 2 and a drop of 1, a run of 2 and a drop of 1. And again, I think I'll stop doing the arrows right now. We can always kind of reverse direction. You certainly don't have to plot all those points. You know, it kind of really is all about how many you need to feel comfortable with drawing a good straight line. All right? I would always suggest more than 2, just so that you can be guaranteed to have a good graph. Let me label that one with its equation, y equals -1/2x plus 3. All right, great. There are my two lines. The coefficient on the x, the number multiplying x, is the slope, and the constant added on is the y-intercept. Remember, the slope is not 2x, it's just the 2. Slope is a numerical measure of rise divided by run. It doesn't include the x, it's the coefficient on the x. Let's take a look at the second part of this problem. This is also from Algebra 1. It says, what is the solution to this equation and why? Right? Now, I'd like you to think about this a little bit, but I don't want you to do the algebra to solve the equation. It'd be a little messy, I'm sure you could do it. It'd be a little messy because of the fraction -1/2. But you should be able to solve this equation somehow by using this graph. Take a moment and think about how. All right, well, let's talk about it. Notice that the 2x minus 7, let me get rid of that larger circle, right, is the y equals equation that we graphed to begin with. And this is the second one that we graphed. And ultimately, when we're solving this equation, what we really are saying is find the x-coordinate that makes these two y-coordinates equal to each other. And that will always happen, in fact, by definition, that'll happen at the intersection point. Now, I'm not asking for the intersection point. This equation only has x in it, and I only want to solve it for x. But the x-coordinate where these two lines intersect, right, the coordinate point itself is at 4, 1. But the actual solution then is x equals 4. And it is the x-coordinate where the two lines intersect. All right. Well, just a little reminder that you can solve equations graphically by graphing one side, graphing the other side, and then finding the x-coordinate where they intersect, or x-coordinates if there's more than one. But with two lines, they can at best intersect once. All right, let's keep going. Okay, now, there are simple lines and there are more complicated lines. What I wanted to do in exercise 2 is look at two extremely important lines, all right, that are also extremely simple, and at the same time try to make a point about lines. No pun intended. All right, let me switch back to blue real quick. Okay, and let's talk about the lines y equals x and y equals -x. Both of these lines are going to be very, very important in this course, and they're both very, very simple lines. But let's see if you can answer letter A. Letter A asks, what are the slopes of these lines? All right, so m equals and m equals. Why don't you go ahead and see if you can figure that out. All right. Well, the slope of y equals x, if you really, really absolutely need to have it in mx plus b form, you could write it as y equals 1x plus b, in which case the slope is 1, or you could say it's 1 over 1. All right. Likewise, this line, if you really had to, you could write it as y equals -1x plus 0. I should have had 0 here. All right. In which case the slope is -1 or -1 divided by 1. Watch out, it's definitely not -1 divided by -1. Negative divided by negative is a positive, so that would be incorrect. All right. Now, letter B asks us to write some, maybe I should put it in quotes, obvious coordinate points that lie on both lines. Now, this is important. A lot of students learn how to plot lines using the y equals mx plus b approach, and they say, okay, I'm gonna plot b, then I'm going to take m, and I'm going to go up 2 and over 3 and up 2 and over 3, etc. And there's nothing particularly wrong about that. But with simple lines like y equals x, y equals -x, right? We also want to be able to interpret what the equation is saying. You see, this line, y equals x, is essentially saying plot all points where the y-coordinate is equal to the x-coordinate. So for instance, the point 1, 1 lies on that line. The point 2, 2 lies on that line. The point -1, comma -1 lies on that line. Okay? Why don't you flesh out a few more and also do some for y equals -x? All right. Well, again, we could do a bunch of them here. 0, comma 0, -2, comma -2, etc. All right? This one may be a little bit harder to interpret, but remember, what that really is saying is that the y-coordinate should be the opposite of the x-coordinate. Again, opposite is kind of a loaded word, but for instance, if the x-coordinate was, let's say, 1, the y-coordinate would have to be -1. If the x-coordinate was 2, the y-coordinate would have to be -2. Let's go in reverse. How about if the -3, +3? How about -4, +4? Lots of different points, right? As well, 0, comma 0. Think about that for a moment, right? What is -0? Well, it's still 0 because -1 times 0 is still 0. So now, letter C. Create a graph of the lines in the grid provided, label with their equations. All right? Even if we didn't say label with their equations, we would anyway because we have two different graphs here. So here we go. Let's do y equals x together. Again, we can just plot a bunch of points. We know 0, 0 lies on it, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, etc. Right? A little more. Still not quite there. There we go. Don't you hate it when your ruler's not quite long enough? All right, there it is. Y equals x. Very, very important line. If you need to plot y equals x, you should be able to plot it just immediately, right? 0, 0, 1, 1, 2, 2, 3, 3. The same for y equals -x, right? We still have the 0, 0 point, but then we have -1, 1, -2, 2, -3, 3, etc. And we get a line that looks like this. These two lines are going to become very, very important for us when we do some work with reflections across lines. And you want to be able to plot them very quickly and accurately without any issues. All right, and we get y equals -x. All right, they're kind of classic lines. This one, if you will, kind of bisects that 90-degree angle, and I guess this 90-degree angle, and y equals -x, that bisects this 90 and this 90. All right, two exceptionally important lines. I wanted to take just a moment in this lesson to kind of plot them for the first time so that we have them down. All right, take a moment though. Let me move Mr. Ruler here and write down anything you need to. All right, let's move on. Great. Now, for whatever reason, many times, you're presented with equations of lines that are not in y equals mx plus b form. And it is very important to be able to do the relatively simple algebra, and it should be at most 2 steps of algebra, to get it into y equals mx plus b form so that you can identify the slope if you need to, and the y-intercept if you need to. So let's go through a little bit of that algebraic manipulation in this next problem. Exercise number 3. For each of the following equations, rearrange it into y equals mx plus b form and identify the slope and the y-intercept of the line. Okay, so in none of these 3 examples is the thing rearranged to look like this. All right? But we've got to get good at doing this because oftentimes, for whatever reason, lines are given in this form instead of in this form. Let's do letter A together, maybe even do letter B together, and then have you work on C on your own. Letter A is very, very easy because when we look at it, the only thing that's on the left-hand side of the equation hanging out with the y is this positive 2x. And we can easily move it to the other side of the equation. I'm just going to write this down again by simply subtracting 2x from both sides. Now, that would normally leave you with something that looks like this. And there's nothing particularly wrong with this, but students can get confused. You know, some students will think, well, the first number I see must be the slope and the second number I see must be the y-intercept. But remember, it's really all about the coefficient of x being the slope and the constant being the y-intercept. So many people could probably take a look at this and say, oh, okay, this and this. If not, you should use the commutative property of addition to swing this around and write it like this. In fact, every time I will. Okay? Because once I have it looking like this, I can then easily say, granted I don't have a lot of room left, but I can easily say that the slope is -2 and the y-intercept is 7. Okay? Let's do another one. So sometimes that's it though. That's all you have to do to get the y by itself. On the other hand, if we look at letter B, what we see is we've got 2x plus 3y equals 12. Now, we've got both a 2x hanging out with the y, and we have it multiplied by 3. Now, one thing that you could do right away if you wanted to is you could use the commutative property of addition to rewrite the left-hand side like that. You don't have to, but you can. This then allows me to easily subtract 2x from both sides. And right away, I'm going to write this as -2x plus 12. Remember, that's a positive 12. If it had been a -12 sitting there, then it would be -2x minus 12. All right? Now we're getting closer, but we need to have 1y, not 3y. So now what we'll do is we'll divide both sides of this equation by 3. And remember, just like multiplication, division distributes. We don't get to just divide the nice things by 3. We have to divide everything by 3. Let me go with a couple steps here. That means we would have -2x divided by 3, and we'd have positive 12 divided by 3. Ultimately speaking, right, then I would have y equals -2/3 x, and of course 12 divided by 3 is positive 4, so that means that my slope will be -2/3, and my y-intercept will be positive 4. And now I have my answer. Okay? Important, right? To be able to get everything on one side of the equation, have it just be y equals so that you can properly identify the slope and the y-intercept. We got one more left. I'd like for you to work on letter C on your own. Take a few minutes. Are you ready to go through it? Let's do it. Now again, similar to letter B, we've got 4x minus 6y equals 7, okay? And we've got quite a bit that we have to do. Again, you don't have to do this, but I think it's helpful to rewrite the left-hand side immediately as -6y plus, and I've got a little bit of a lag on the board right now, which is interesting, plus 4x is equal to positive 7. All right? What I'm going to do is I'm going to get rid of the 4x by subtracting it from both sides. All right? I'll get -6y is equal to -4x plus 7. Now I have to get rid of that -6, so I'm going to divide both sides by -6. This is going to get ugly. And I'm going to get y equals, that's good at least, -4x divided by -6 plus 7 divided by -6. And this is ugly. We got fractions everywhere, negatives everywhere. It's not pretty, but at the end of the day, it is what it is. And here's what I mean by that. Let's kind of finish this up. We'll have y equals whoops, let me get rid of that. We'll have y equals -4 over -6x. And then I think what I'll do is I'll just make that -7/6. I'm going to change that negative divided by a negative into a positive. I'm also going to reduce the 4/6 into 2/3. So although it took a lot of work, we got all the way there, which tells me that the slope, I apparently really love 2/3. The slope is 2/3, and the y-intercept is negative 7/6. Okay. It'd be lovely if every time we had to plot a line or identify its slope or its y-intercept, it was immediately written in y=, form, okay? But oftentimes it's not the case, and we have to have confidence that when we look at an equation of a line, and we know it's the equation of a line because neither the x nor the y has been squared or raised to any higher power, we have to have confidence so that we can rearrange those equations and get them into y= form. All right, take a moment and write down anything you need to here. Okay, let's move on. No scrubbing the text this year. It just stays there. All right, now let's kind of get into a little bit more work with lines. Let's take a look at what exercise 4 asks. On the grid below, the line S is graphed as well as the point 2, 4. Letter A, draw a line parallel to S that passes through 2, 4. Write the equation of the line below. All right, this is cool. This puts together a lot of what we've been doing both in this lesson and a couple lessons ago when we looked at parallelism. All right, I want to draw a line that's parallel to S and passes through that point. Okay, so take a few minutes and see if you can do that. All right, well, first things first. A little review. Two lines are going to be parallel if they have equal slopes. So I got to figure out what the slope of S is, and I think I'll just do that graphically. Let me take a look at S, and what I see is if I pick a nice point like here, and I just kind of keep looking at it, what I can see is that for every 2 units I run, I fall 1 unit. So S has a slope of negative 1/2, which means the line that's going to pass through this point also has to have a slope of negative 1/2, and let's give it a slope of negative 1/2. Let's come over here and let's run 2 units and drop 1 unit, and then run 2 and drop 1, etc. All right, that's probably plenty. Bring my ruler up, rotate it down. Yeah, that's pretty good. Okay, now the question is, what's the equation of that line? Well, remember, right, we want the equation to look like this, y = mx + b. Hey, it's been a little while since my random red came up. I'm going to just erase that and put it back in blue. It's still red, but over here it's blue. Ha ha. Ha ha ha. We're just going to let the red B hang out. I don't even know why it's there. Anyway, so we needed y = mx + b. Okay, we already knew what the slope was. It's negative 1/2. And of course the b is the y-intercept. And what is that y-intercept? Well, it's 5. We can just look at it right on the graph. Okay, so the equation is very simple. Y = negative 1/2 x plus 5. That's it. All right, let's deal with some perpendicularity. Letter B. Draw a line perpendicular to S that passes through the point 2, 4. Write the equation of the line below. Why don't you take a few minutes and go ahead and do this. Remember, you'll have to go back to what we learned about perpendicular lines and how their slopes relate to one another. Good? All right, let's talk about it. Well, remember, the slopes of perpendicular lines are negative reciprocals of one another. In other words, you take your slope, you flip it, and you change its sign. So in this case, right, that slope of the perpendicular line, right, will be a positive 2/1, or just 2. Now that's going to be enough to allow me to plot that line. Maybe I'll go in red, which then will probably mean that magical blue color will just show up somewhere. But let's go ahead and do it. Let's come over to our point, which, you know, I kind of lost a little bit. And let's do a slope of 2. So that means I go over 1 and up 2, and then to the right 1, and then up 2, right? And I get, hopefully, more points like this. All right, that's going to be plenty. Let's bring my ruler back up. Bring it down. Rotate. I don't know why I have to walk you through all of the little different things I have to do to get my ruler to work. Hopefully you just have a nice, normal, non-virtual ruler. All right. Go back down like this. Oh, yeah. I don't know what just happened there. Go back to blue. Lost my little 2 there. Okay, that kind of looks like a 2. All right, well, let's take a look. We need to write its equation. What do we need? We need its slope, which we know is 2, right? And we need its y-intercept. Well, its y-intercept is actually the origin. It's 0. So you could write the equation of this line in 2 very different, well, not very different ways, but slightly different ways, right? You could either say it's y equals 2x plus 0, which many students will prefer because they want that y equals mx plus b form, or what I would certainly prefer as a teacher is just to see students writing down y equals 2x. In other words, every point on the red line is one where the y-coordinate is simply twice the x-coordinate. Even the 0, 0, if you think about it, although it seems a little bit weird, but you can even see it, right? Here we've got the point 2, 1. Here we've got the point 4, here we've got the point 1, 2. Here we've got the point 2, 4. All right. In every case, the y-coordinate is always just twice the x-coordinate. But that's it. And again, the nice thing about this problem is it allows us to review the parallelism and perpendicularity conditions, plus get that y equals mx plus b into the mix. All right, let me step back. Let me toss some ruler out of there. Maybe kind of bring this up, so you can see the work. Step out of the way and copy down anything you need to. All right, let's move on. One more problem. All right, kind of a simple wrap-up problem, okay? Exercise number 5. Which of the following lines is perpendicular to 10x plus 6y equals 12? Okay? One of these 4 lines is perpendicular to that one. Which one is it? Take a little bit of time. All right, well, what we know is that when we have 2 lines that are perpendicular, we get those slopes that are negative reciprocals. But that means I've got to be able to identify the slope of that line. And that line's not in y equals mx plus b form yet, right? So I got to work a little bit. Let me take this thing, bring it down here, maybe just rewrite it. 10x plus 6y is equal to 12. All right, maybe use the commutative property of addition to rewrite it as 6y plus 10x is equal to 12. Subtract off 10x from both sides. Watch out, don't combine those two. This one doesn't have an x, this one does. So really I'm just moving something to the other side. Y equals negative 10x plus 12. Divide both sides by 6, right? Gives me y equals negative 10 sixths x plus 2. Think about that for a minute. I just did 12 divided by 6 and negative 10 divided by 6. And now let's reduce this one by dividing both numerator and denominator by 2. Now again, be careful. It would be easy enough to look at that particular equation, go up to here and go, there it is, choice 1, negative 5/3 x plus 2. I just got it. Except that wasn't what I was looking for. I'm looking for a line perpendicular to this one. That's the exact same line. It's not perpendicular to this one. It's not even parallel to this one. It's the same line, just in a different form. My purpose was to really come in, look at this, and say, the slope of my line is negative 5/3. So therefore, a line perpendicular to it will have a slope of positive 3/5, and that would be choice 4. Now, what some students will get confused by is they'll say, yeah, but What about the 2? I mean, that's a 2 over here, and it's a -7 over there. Perpendicularity has nothing to do with the y-intercept. It's all about the slopes, right? It has nothing to do with where it intersects the y-axis. So yeah, this line intersects the y-axis at a y-coordinate of 2. This one intersects the y-axis at a coordinate of -7. That's completely okay. What matters is that relationship between their slopes, which we could only identify if we rearranged this into y equals mx plus b form. All right, let me get out of the way. Again, take a little bit of time if you need to. Okay, let's move on. Move on and wrap up. So today, we just really reviewed, right? We looked at the classic y equals mx plus b form of a line. That's called the slope-intercept form of a line because when written in that form, you can easily identify the slope of the line, rise over run, and the y-intercept of that line, where the line crosses the y-axis. All right? Simply by knowing that, and also knowing skills like how to rearrange lines to get them into that form, we can both plot lines and we can look at the perpendicularity and the parallelism of lines. That piece is a little bit new to this course. Everything else you saw back in Algebra 1. All right, we're going to work a lot more with this in the next lesson. For now, let me just thank you for joining me for another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.